by the way. I've actually started reading this thing.
Oh, good.
There it is.
God, it looks backwards though. Why would that be?
I don't know.
Only to you. The rest of
Oh,
us
it
is
looks
fine.
good to us.
It looks
Yeah.
fine.
It's fine.
Okay.
And they even
It's fine to us.
spelled envisioning right, which was good.
Yeah. So
Yeah.
it's envisioning exoplanets. Most of you, I think, were on there when Mikey did his
Yeah.
talk, searching for life in the galaxy. And you can get it on Amazon, I think, still, Mikey.
Yep.
But I bought a copy for a friend of ours for, well, I don't know if Kelly's on there yet. Oh, good, Joelle's there. I was going to call her to remind her.
Hello.
Yeah, so I got one from the Boulder bookstore. So,
Great.
you know,
So you can pay your mortgage now.
support our local bookstores when you can. Yeah.
Okay, Mark's showing you our Christmas tree.
Oh, I love that little thing. Where did you
Yeah.
get that?
Target.
Okay.
Well, if we get a big Christmas tree and do it all up, the cats just pull it down. So
Yeah.
we got this one.
I love your background. Very cool.
Oh, mine. Yeah. Well, it took me a while to get
Yeah,
up
you
there.
can see mine. It's against the window.
Oh,
Yeah.
yeah.
Just those pretty lights.
Nice.
Everything is sort of above knee high because the new dog takes it all away.
Oh yeah. Yeah. They don't. You don't own any. You don't own anything. They do.
No, yep.
I haven't
Just
seen you guys
asking.
out walking too much, Judy. Is that dog owning you at home?
That dog would go for more walks than I would, but I'm not going out in that wind. I might never land again.
You land in Kansas.
I don't
The
like
epicenter.
Kansas, okay?
I'm sorry. I have to leave now.
Okay. So I think we can get going here. So yeah, John's back, John Williams, and just want to thank everyone at the very beginning here, not just for showing up, but you know, John's just unbelievable. He actually did his part of our Mountain Messenger story today to our article. And then I didn't tell you, John, but I found an old email from the editor of the Mountain Messenger saying it's not due till the 28th. So we got another week. Sorry about that.
You see my face really close?
Yeah, I don't like that face.
I guess we're lucky we're not doing this in person. Barb would be in a lot of trouble.
No. Actually, it was good for me to get it done. You know, it was just like, done.
Done.
Yeah, really.
I mean,
Don't
there's something to
change
say for
anything.
that, right? Yeah, I'm not going to change. Well, I guess
So,
things
yeah,
could,
if
there's
there's
nothing
a-
that can change. So, you know, it's in the stars.
That's good. Okay, so do you want to go first?
What are we doing
Okay,
here?
so John, yeah, if you have Leonard's PowerPoint, maybe we can go, if that's okay with you, first,
Yeah, sure.
with Leonard. And then maybe before you do yours, we can do some of the astrophotography.
Oh,
that people
sure.
sent.
I have my, yeah, I have the astrophotography before the stuff I was going to talk about. They're
Wait,
part of
no,
the same.
well, go ahead and, or whatever you want to do.
Here, no,
Fine with me.
I'm bringing up Leonard's, and it's just going to take. Oh,
Yeah, let me get out of the way here. A lot of stuff happened.
hold on. Gosh, I apologize.
Oh, and Jen Waddington had suggested,
Yeah.
she wrote to me, that after each of our speakers, we unmute everybody, or you can unmute yourself and clap for the speaker. And I thought that was a great idea.
No,
Thank you,
might
Jen.
wanna clap.
Okay.
Can you
That's
see?
done. Perfect.
Can you,
Well, that's
Good.
good. I got the right date.
Yay.
2020.
Yeah, that's fine. For me, just as a reporter, You know, I really follow the Chinese space program quite a bit. Okay, and there's a lot of Chinese chatter on this thing.
Yeah. Hey, John, can you, I think you need to mute Jan.
I did.
Okay,
Okay.
great. Here we go.
Well, you know, the Chinese pulled off something fairly significant here. And, you know, I'm kind of a really judicious follower of what the Chinese are doing. They pulled off this Chang'e 5 lunar landing and for sample return, bringing back samples from the moon. This, to me, was one of the more complicated robotic missions ever done. And it mimicked, this is what I'm trying to get across to some editors, that it is pretty much the Apollo mission on robotic steroids. They did every increment of what Apollo did, but robotically. They landed this damn thing. Okay, next slide. Okay, they had an arm come out, grab a bunch of samples, put it into the container, you know, on the moon. Then they blasted the container off the moon into lunar orbit, where the Chinese, you know, one of their modules was up there already, or orbiter returner. They rendezvous with that thing automatically, and they transferred the samples that they gathered into the return capsule. Okay, next slide. Maybe I should be. Okay.
Yeah.
Okay.
Is that the right one?
And they had a
It
thing
may
called the I'm
delayed
sorry,
there.
John.
Yeah.
They had a thing called the returner capsule, returner orbiter capsule, and this thing flew back to Earth. And the thing in the front is the capsule that they transferred the lunar samples into. Okay, the next slide. Okay, they have the whole mission was kind of a four-part lunar program. It had what they called the orbiter. They had the ascender from the moon. They had the rendezvous capsule. They put it in the capsule. They bring all this stuff back to Earth, all autonomous. I mean, the amount of, and I followed it really close. So I'm more than close to what they did. The automated capability that they experienced in lunar orbit is pretty challenging. I mean, you wouldn't believe the mechanisms that were involved to gather this stuff up, jam it into the return capsule. Next slide. Then fly this thing back to Earth. And they picked it up in Mongolia just last week. You know, they picked up this, we watched it live on China television.
In Chinese.
Unbelievable.
In Chinese.
Within 30 minutes, the recovery crew was in Mongolia in the worst condition you could ever imagine a return sample coming in. They were so cold. All the commanders, even on the China television, they were going, "It's so cold here." They picked up this damn thing. It's you know, the whole mission of Chang'e 5. I'm going to stop talking about it, but it's about an 8-ton spacecraft. All the elements that they had to do within 8 tons of these different modules that had to transfer the. Okay, not this one.
I'm sorry.
They're about done. You know, they're just turned over the lunar samples into China's lunar receiving lab. And that's on the right there, you'll see the actual return capsule. They got quite a bit of samples. It's pretty impressive.
How many pounds?
I can't remember what I wrote.
Black.
Quite a
Yellow.
few. They got quite a bit of material. And no. Okay, next slide. They weren't the only ones coming back with return samples. It's Japan.
Japanese.
The next
Yep.
slide. Here they are in Woomer, Australia. The Hayabusa 2 grabs, it's been going for, what did I say, 6-year mission. Goes to asteroid Lehmkuhl, samples the asteroid, and brings it back and lands in Woomer, Australia with the samples. Next slide.
And these guys had face guards.
Yeah, I think that's one of the clever titles, hors d'oeuvres.
Yeah,
Okay,
that is-
here's the guy.
it looks
This is
like-
what they got back. Out of that entire mission, they got this little sample container that they parachuted back to Earth in Australia. They picked it up. Okay, next slide.
carried it.
Here's, one of the sample containers had this material in it. This was sort of a sample of the asteroid that they're going to analyze. And they actually got, what did I say? I got to read what I wrote.
Was that what they thought looked like coffee?
It was more than what they thought they got. And it's pretty much, what was really funny about this, when they released this picture the first time, they took it in the curatorial lab under kind of strange lighting, and everything looked like coffee. It looked like coffee grounds. And people were going, it's coffee grounds. They got coffee grounds. And they readjusted the thing to actually show today, yesterday or last night or something, what the sample really looked like. It's black. It's going to be telltale. They got a couple times or 3 or 4 times more than they thought they got. They're still opening the canister from this Hayabusa 2 experiment. Tremendous experiment. Japan, keep an eye on them. They're going to do some really incredible things with Phobos on another Mars mission robotic. It's going to be great. So next slide. You got to remember 2020 was pretty much a Mars year in the sense of people lobbing stuff to the red planet. The United Arab Emirates, they're on track. All these missions are going to be getting to Mars in February. This is the Uae Mars Orbiter they launched. Okay, next slide. It's an orbiter. It's not a lander. It's going to orbit the red planet and do a lot of climate studies. Great mission for them. It's really an introduction to what UAE wants to do on Mars. People haven't picked up yet on what they really are thinking they're going to do. Next slide. This is their team. That's the orbiter that they're going to, that's en route.
That's big.
Yeah, it's big. Okay, next slide. Back to China. They lobbed a Mars craft to the red planet as well. It's en route. It looks pretty healthy, and they are jacked up big time because of the moon sample return mission. I wouldn't discount how this is going to go. It could be a failure. It could be a great new success. They have not only a lander, but they have a rover they're going to deploy on the Mars. And next thing. And there's sort of a collage of what they're hoping in February they're going to, or actually they're going to loiter around Mars for a while and make sure they get the landing site right. And to me, that moon mission they just finished kind of bodes well for their capability. And we'll see. I mean, Mars is always a treasure trove of disaster. So you can always have problems, but they're going to do their thing. And we'll see if they get their rover down on Mars. Again, February, May for them, I think, is where they intend to land in next year. Next one. And then we have the NASA Perseverance rover that's en route, going to land in February. We're talking February landing, and
February 18th.
yeah, February 18th. Thanks. And what's so cool about this is that it carries quite a bit of creds. I mean, it's got a helicopter it's going to unleash to do some, in the atmosphere of Mars, kind of traversing. Also has an experiment to actually convert the Mars carbon dioxide into oxygen as a precursor for what Mars, astronauts in the future may rely on. As always, these things can crash. And I've been there when they have crashed on Mars at Jet Propulsion Lab, and it gets to be ugly. But, this is a major NASA experiment that also sets up the stage for collecting return samples that other pieces of the Mars architecture in the next few years will actually go grab and haul them back to Mars. So we have actually in this one mission, it's a lot on the plate of that thing. It costs a fortune. I have high hopes and low expectations that everything's going to work. It's a pretty gutsy endeavor, and we'll see how they do. But that's coming up. So next year is going to be Mars-orama with all the UAE and everything. And one of the things that happened just a few weeks ago, Spaceship Two. This is the Richard Branson Virgin Galactic super extreme tourism for suborbital people that want to pay how much? 250?
No, I think it's 500.
500,000 a pop? I don't know what the number is for the seats. Anyway, they're going to start flying suborbital passengers out of New Mexico. They had their first trial run out of New Mexico Spaceport called Spaceport America. It's a huge facility. Barb and I have been up there a lot of times. It's incredible capability they have on the ground. Now they got to prove that the Virgin Galactic Enterprise can actually fly out of there and take up suborbital tourists at big paychecks and come back down. Well, they got up for the first time. They had a trial run with 2 pilots and no passengers. They got up to detachment from the
White Knight 2.
Yeah, the White Knight 2 aircraft that takes it up to 100,000 feet or so, deploys the spaceship. Well, they had an abort. They had to come back down. So it was a little bit of a disappointment. This is their introduction at the end of the year that they're ready to go. But clearly nobody died.
Yeah.
The pilots flew the damn thing back, and it was successful in the sense of just trying out the runway. The runway held up.
Yeah.
Everything
And
else
then
kind of cratered, but
the upper left there is the terminal, which is it's hard to see it from in this picture, but it's very beautiful.
yeah, and the left is the terminal, which is really have been maxed out by Virgin Galactic. I mean, it's you can wear your pajamas in there and have a nice flight. It's pretty cool. So, that's coming next year. They're going to, they learned a lot, and they're going to fix that. And my guess is the, next suborbital try from New Mexico will happen pretty shortly, early next year. So that's coming. So keep an eye on that. It's going to be fun. Next one, I don't know what's happening. What is the next?
Yeah,
Oh.
yeah.
And we got Elon Musk. My God. You know, he's done so many damn things. And then he has a starship. He wants to take people to Mars. This thing was a test of a starship from Boca Chica, Texas. And it's not Vandenberg. It's not
Boca
Cape
Chica.
Canaveral. It's Boca Chica.
Yeah.
And it took off and it did everything it was supposed to do. But they had a problem on the landing and it cratered and exploded. But, you know, Elon Musk said they got a lot of good data. And, you know, from everybody I know, they did get a lot of good data. So he put a leg up on Mars here with a starship. Pretty incredible flight. Next slide. Elon had a great year. I mean, he must be very, very happy. He launched astronauts in his Dragon spaceship to the International Space Station, not only once. Next slide. Next mission, a lot more people. Things are cooking along there.
And we used to have to rely on the Russians.
And we used to, you know, rely on the Russians to get our astronauts off the ground from America, you know, from anywhere into
To the space.
to the space station. So things are cooking pretty well for him. Keep an eye on Boeing. They're coming along. They have their own vehicle that they've been contracted by NASA. We'll see the first flights of that. There's a lot of movement in the whole NASA Artemis program. That's going to be key to whether or not NASA is going to be able to launch any humans to the moon by 2024 or somewhere in that vicinity. So it's a great, you know, as much as we all wring our hands about 2020, and you got to give it to the people that help these missions happen. Everybody, China, Japan, US, to deal with the coronavirus, to get these missions off the ground and be successful. Pretty incredible.
Is that your last one?
That's it, I think. Oh, no. There.
So what is?
There's my going away slide. One of my best friends, Larry Kuznets, is a U.S. He's at USC Berkeley, and don't tell anybody, but Larry was my inside guy during the Columbia accident investigations. They gave me a lot of really interesting information. Columbia with the accident, and we had lost the 7 astronauts on the way in. Space shuttle.
And when was that? About 10 years ago?
Anyway, Larry has been working on spacesuits for Mars. And, you know, he has always said to me that if I get a Mars suit, this is forward, backward contamination on Mars. We got to be careful. I think I got a spacesuit here that's good for the coronavirus and beyond. And so he has developed a new spacesuit. And next slide. He's actually testing this in Hawaii with a medical unit. And so he's come up with a new suit design that may be not only for Mars, but also to deal with pandemic. And I found this pretty incredible. This guy is, you know, he's worked for 50 years with NASA. And he's an outsider, but he's got inside knowledge about how to be creative and innovative. And I think he's onto something. So, you know, as much as we're waiting for inoculations, you know, I'm waiting for my suit. So I think that's it. I hope. Oh, there it is. You can't expect anything more. Come on. Again, watch the International Space Station. I think we got some real issues there. And next year, they're kind of telling about its longevity in Earth orbit, its viability. You know, the Russians are having problems with their module, you know, leak rates and all this stuff. But, you know, this thing's getting old. So we'll see where we're going. But anyway, Saxon space. They're playing my tune. Okay, kids. Thanks.
Oh, okay. Unmute and clap.
All right,
A lot
next.
of mass in a saxophone. That's a lot of mass in a saxophone. A special thing to be able to take into space.
Yeah. So, John Williams, if you want to, wherever you want to go, we've got Bob Grimm is going to give us an update on Venus too, but wherever you want to put him in is fine with me. Hello.
I was unmuted. I was sitting there trying to find the mute button. It's funny because when the Zoom takes over, or my presentation takes over everything. Do you want to go now, Bob, or do you want to wait?
No. Oh, you're muted.
Unmuted.
I don't care, whatever you want to do.
Well, I was going to let you choose, but you know. if
Okay,
you're
well,
not
I have to
done,
take the screen. So whether you want me to take the screen now or you want to keep
Go
the
for it.
screen because you're doing Leonard, that's
Nope.
okay.
we're done with Leonard. Go ahead, take over.
Okay, this will be fast. I mean, just because it's so crazy.
Yes.
So you know, we did this thing a couple weeks ago about what was going on with Venus. That there was these new ideas. Let's see, about this chemical compound had been discovered, phosphine, which is pH 3, and it's rare on Earth. It's not quite as rare on Venus, and the dominant way that it's thought to form is from it's known to form on Earth is from bacterial action. So this group of astronomers using radio telescopes were going to look at various stars that have exoplanets, and they were going to look for this phosphine as a biomarker, as an indicator of biological activity. And they said, well, let's just test it on Venus because we know there can't be anything on Venus, and we can make sure that we get nothing when we look at Venus. And they got something, and it was just a few parts per billion. But there was some companion papers that suggested that there's no way that this could arise from any atmospheric process or geological process. And so, however unlikely, the remaining idea was that it was from life. So what's happened in the meantime is there's been sort of a two-pronged attack, and they've been defending as well, where many people tried to reproduce their results, and there were some technical issues that I think even Clark brought up in some early discussions, both here and at work, about looking at different wavelengths. They haven't fully done that yet. There's some issues with how data are processed. There's something called ripple in the processing that they're arguing about, but it's a very vigorous and largely civil debate that people are posting all these preprints and submitting them to journals. And so even before something gets formally published, somebody else has a response to it. So it's moving pretty quickly in terms of the observational arguments. I kept wondering, well, there's got to be something else that can explain it. If in life, that'd be really exciting, but we got to rule everything out first. And these two guys, Jonathan Lenine and Trung here, have done a model where the phosphine is from volcanism. Now, there's this paper by Baines and colleagues. This is the new AGU e-format, by the way. You do a poster and you click on these different parts so you can watch it online, but it's very rigidly set up. So they're saying that basically that even though these guys, Baines, said there's no way you can make it any other way, that they say, well, you can make it by conversion of iron phosphide, which is a compound produced in volcanic eruptions, and it can react with the sulfuric acid in the atmosphere. And they say that the chemical conditions for Earth are okay for this, but they say there's a certain amount of volcanism is required to make it. So just to skip to the good part, well, there really is no good part. It's a scientific poster, so it's all going to look the same. Yeah. So the answer is that they need, in order to get the 1 to 5 parts per billion in the atmosphere of Venus, they need to inject something like 0.1 cubic kilometers of ash into the atmosphere per year to make that. And then they say this chemical reaction can take place. Let me skip over to here. They say, in fact, these are all the numbers for phosphine that's been measured on Venus, sorry, on Earth. And the Venus one is like up here, like a factor of, 100 or 1,000 bigger. And they say that, there's a reason, there's a geochemical or atmospheric chemistry reason why the Earth has so less, because we have a lot of water, and OH in our atmosphere just destroys all this phosphine, whereas it would be hanging out in the atmosphere of Venus. And so they say, well, if we have enough volcanism, we can get this 1 to 5 parts per billion compared to the parts per trillion that we see on the Earth. So this got me really excited until I read the fine print, which was, well, where does this 0.1 cubic kilometers per year of ash comes from? It comes from 10 cubic kilometers per year of lava. So you have to put out 10 cubic kilometers per year of lava and ash to get this 0.01 to go up high in the atmosphere and react and be observable from the Earth. And the problem is that for every cubic kilometer of lava that comes out, there's probably 10 cubic kilometers that is intruded into the crust and hides in the crust and never gets out. So Venus would have to have like 100 cubic kilometers per year of total magmatic activity, stuff that we saw at the surface, stuff that built the crust up as well. And the number for Earth, which has plate tectonics, where we pull the mid-ocean ridges apart and make new crust on a gigantic global conveyor belt, that number for the Earth is only 20 cubic kilometers per year. So even though there's been various studies of Venus that say there's these sort of hot spots and it could be volcanically active, for Venus to have 100 cubic kilometers of lava a year would be pretty astounding. So I think this just says that the answer to the Venus phosphine is still that nobody knows. The life explanation is we got to thoroughly rule everything else out before we come to that. This has looks like it was getting legs, but I think it's got its own problems. Meanwhile, people are poking at every one of the rest of that list of other ways that you could make this stuff, while another groups are also looking at the observations. So it is one of the most vigorous scientific debates I've seen in my lifetime still. And what's this is the kind of thing, this only came out in I forgot when, October. And so the American Geophysical Union meeting, the slate was completely set for the meeting, but when there's late breaking news like this, they'll do special sessions. Now, the fact that we're all, remote makes it easier to just add one. But they got, a big slate of authors together to record talks online and have a live session. So I'm back where I started. The scientific community is fully engaged in responding to this, and the science, I think, is being done correctly and civilly by all parties. And it's only been a couple of months. We don't have an answer.
Hey, Bob, remind me, does phosphine break down in Venus's atmosphere, or is it just cumulative, builds up? Where do we know? It does have a lifetime.
I forgot what it is. Maybe he talks about it over here. But it's got to be long enough if they're assuming that basically that it's being generated by bugs or something that float in the atmosphere, and yeah, I don't know the answer to your question, John. It's probably how fast is it on Earth? Oh, here we go. 100 years on Venus. So it high up in the atmosphere, like at 60 or 70 kilometers. So where it's kind of Earth-like temperatures, it'll still break down, but it's not broken down as fast as it is on Earth because there's not all these OH radicals floating around.
Bob, if you were a betting man, what would be
I am
your
a betting man, Clark.
Huh?
I am a betting man. I take all kinds of stupid risks.
Okay, well, what would you guess is the likely outcome as to whether the phosphine is there, and what do you think is the likely chance that life is the answer to why it would be there?
I'm not qualified to talk about the phosphine detection. It's radio astronomy. But of the two groups that have most strongly criticized the result, one of them still puts an upper limit of a few parts per billion, and Greaves came down to like a few parts per billion. So at least two groups are saying, well, there could be a few parts per billion. The other one says non-detect, it's all bogus. What can I say about whether it's life? I mean, that would be the most amazing discovery in the history of science. That's why I'm following it. But
well, it's one thing for people like you who love Venus to follow it. Should it have made the big splash in the public media that it did?
Well, I mean, come on, we have presidency by tweet now. I mean, everything has changed.
That's a low bar.
There's and that's an extreme example, but the idea that people regularly have press releases and there's a hungry people want to read stuff, but this did go to Nature, right? I think it was you actually who commented early on that you thought the tone of the press conference, which I did not see, was much more out there and favorable to life compared to what the Nature paper read. So yeah, maybe it did get spun up a little too hard, but yeah.
Hey, Bob, I've lost track of implications of this research, known, unknown, and its impact on decision-making for a new Venus craft that should go there. I mean, what's the latest on how you see anything happening with the actual new spacecraft going to analyze this data?
Well, there's only one spacecraft that's in the current queue that could do it, and that's Da Vinci. And that's one of 5 spacecraft that are competing that are in a final selection process with NASA to be announced maybe in the spring. And NASA is famously close-lipped about when they're going to make these decisions, and it really comes down to the associate administrator, Thomas Zurbuchen, and what he thinks, or whether he'll still be in that job in mid-spring. I don't know. I think it's I think the mission is compelling. There's 2 Venus missions out of the 5, and I think they should pick one of them. But there's more considerations, like which NASA center is getting work. That they use that too. I mean, at this point, all five of these proposals are supposed to be equally valid scientifically, and it's just a matter of which one does NASA think is going to work. Have the best chance of working with the least cost overruns. But Zurbuchen's the kind of guy that might just say, "I like this and I want to do it." So it's an unknown. There's also some private companies.
Yeah. Do you think this is the last gasp for Venus? If they don't pick anything for Venus, is it, that by the time we come around and look at spacecraft missions, and there's so many that are compelling today, is this the Venus window?
No. What has to happen is something has to crack the door. You've heard me say this before, that that, my generation that did Magellan is approaching retirement age. There's kind of a lost generation of a handful of people in between, but there is a new generation of people, who are intensely interested in Venus. And, when they get a critical mass, then there'll be, even more missions and more ideas. I mean, asteroids, why do we have this asteroid sample return? Because asteroids are, have been done before. They started in Discovery. They've been done a lot. And so there's a bunch of people that work on them and want more asteroids. So really, I think it's a matter of the community, and there has to be enough new results out there to get more people interested to get it to go. Keep in mind also that the Russians are still floating around an idea to go to Venus with a big mission. And then among the Europeans, their so-called medium class 5 call is down to 2 missions, a Venus mission and something else like an astrophysics mission. So, it may be in the 2030s, right? I won't be active in the field anymore, but it's not like it's never going to be a Venus mission.
Okay.
I have a question.
Sure.
Well, if we had a Venus mission, would you want to see an atmospheric probe with a mass spec?
So I mean, there's the 2 schools of thought is an atmospheric probe and or a lander, and then a new generation, more capable radar orbiter, possibly with infrared capabilities and other stuff like ground penetrating radars. I'm a global geophysicist. I'm more interested in how the puzzle pieces fit together, what the surface looks like. So I mean, my personal interest is in the radar. I'm also interested in balloons, but along the lines of what I said, if this atmospheric probe flies, it'll release. There'll be a whole bunch of new people working on Venus. There'll be new questions asked, and there will be new missions proposed. There'll be momentum. Without any momentum, everybody just kind of shrugs their shoulders. So yeah, I'd be happy to see the probe first.
And then I have kind of a follow-up. If we were to detect phosphine with a mass spec, would isotopic ratios of hydrogen show anything, or like life versus not life?
So the only isotopic ratio in hydrogen is deuterium, at least that I know of.
Right.
And that basically talks about atmospheric escape. There's no partitioning of that with life like there is with carbon. And so yeah, people are interested in the D to H, but more to understand like how much water was lost from Venus. There are people looking back at the Pioneer Venus mass spectrometer from 1980, I think, and it's been claimed that they see phosphine in it. And there's a bunch of people claiming that an instrument can't see that. So
I got a question here, Bob. Back in October, there was an article in Science News about the phosphine discussion. And then in the latest issue of Science News, somebody sent in a letter, and part of the asking about it, and part of the response of the letter says, other research groups have been questioning the phosphine detection. Quote, and this is a quote from the person who wrote the original article. Based on reanalysis of the data, one of those groups suggests the phosphine signal actually was sulfur dioxide. That would mean there's no reason to get excited about possible life signs, at least not yet.
Right, so that's the first of the 2 groups that have challenged it. And it has to do with, it's a radio telescope and it involves like Doppler shifts is how they look at the molecule. I mean, the instead of it being like wave number or wavelength, it's kilometers per second is the x-axis. I don't understand it, but it's a wiggle, and they have to fit a high order polynomial to it to pull out all this background. And you can imagine it's a 12th order polynomial. So you can imagine that if you get that wrong, you could introduce wiggles back into it. And that was the source of the argument. And this other group was saying, well, sulfur dioxide, if you fit it in this way, you'll put this wiggle where your wiggle is. So that's just part of the ongoing argument.
Okay.
Go Venus.
Go Venus. Exactly. Anybody have more questions for Bob?
Oh, yeah, wait, we got to clap.
Okay, thank you.
Can't unmute everybody all at once.
Thank
This is really
you.
crazy.
Yeah, thank you,
Thanks,
Bob. We appreciate that. Really. So, John, what do you want to do the astrophotographers shots next, or do you want to do yours?
No, they're the astrophotography's first, and if we have time for mine, so be it.
No, we gotta have yours. But don't leave us.
Oh, my daughter said, yeah, we're here for 2 weeks, so do your thing.
2 weeks. Wow. Okay.
I know.
Wow.
I don't know what I'm gonna do. Plus her dog's here, so I really like that dog. So I may just steal it. Anyway, hey John, you're up first.
All right. Well, I got lucky. It was clear on Wednesday night. So I did a little looking in my planetarium program and saw that, hey, I might be able to see this. And as you can see, I just barely got it through the trees. And I'm hoping to get more shots. Tonight was the second best night, just by a little bit, for having the planets really close together. Because
just to review, the brighter one's Jupiter and
yes,
the other one's Saturn.
And the smaller one is Saturn. And the moon was closest to the pair on Wednesday night. And it was actually off to the left of the pair on Thursday night, which some people got a shot of and some people didn't. And I didn't see it really too well. I mentioned before the meeting started, I was hoping it would be clear tonight and I would have got a few more shots before the meeting of the really close planets, because the actual closest approach, I think, is maybe 12 hours from now-ish. And we're seeing it tomorrow night, just a little bit after the closest approach. So tonight would have been second best. And it was cloudy last night, so I couldn't look at anything, but I did go set my mount up outside and then leave the tripod where it was and took the equatorial head off and put that in the house so it wouldn't be cold and expose the elements for a day or 2 or 3 whenever it's clear again. But at least I got something. Yeah. And then I think there's another follow-up picture to that. That's a close-up of the same frame.
Wow.
Really blown up, and it's in the lower right of Jupiter. There is Ganymede, and the upper left is Callisto, and you can actually see Titan barely to the lower right of Saturn. This has been contrast enhanced quite a bit, so they're pretty faint on the shot without boosting the contrast.
I think everyone probably knows this, but yeah, those that you're naming are the moons of Jupiter and then moons of Saturn. And do you know how many? Yeah, I mean, we see 4 bright moons with Jupiter, but how many moons does Jupiter actually have? Do you know?
Something like 70. Saturn and Jupiter both have well up there in the upper 60s or 70 moons, but a lot of them are really tiny. And there's a few others you can see of these. Like, I think there's one around Jupiter called Himalaya, but you need Jupiter up there high in the sky and a really dark sky because it's about 15th magnitude and a medium to large size telescope. Also, there's about 6 or 7 moons if you're going way out with Saturn and really deep. But yeah, they need to be up there like at least 45 degrees up in a nice dark sky. And good seeing, because the seeing benefits the image size of the moon and makes it a lot brighter apparently, and when you get down to the real faint things. But I wanted to add a couple things about Leonard's talk real quick. You know, SpaceX launched its 26th Falcon 9 of the year yesterday. And there was a couple weeks ago, they launched the new cargo Dragon. I think it was 2 weeks ago. And I happened to go outside for a walk when the space station was coming over on the same night that they launched, and they were going to dock to the space station the next day, the next morning. And I saw the cargo Dragon go over about 2 minutes or a minute or two before the space station. And it was real faint. It was about second, third, 2.5 magnitude, you know, fainter than Polaris. But anyway, just wanted to throw that in as a, you know, more space news.
Hey, John, one thing that I'm seeing in the morning, I'm pretty groggy when I get up, but this morning I went to the window at about 5 o'clock in the morning. You're really starting to see satellites that are pretty tight. You know, they're right in the they're right after each other. I mean, we just launched the OneWeb constellation went up just the other day. You got Starlink from SpaceX, but I keep an eye out on these multiple satellites going overhead. You can pretty much see them. I mean, at least I think that's what I saw, but I was groggy before my coffee.
I've seen them. I saw them once every 10 seconds or so. They were going over. But most of this, well, it's not as bad in the winter as it is in the summer. During the summer, some of these things you might see all night in the north, at least. Anyway,
Dave, you're up.
Great imagery.
Oh, thank you. Wow.
David Elmore.
David?
That looks like a David Elmore.
Looks like a heart.
You're muted, David.
Doesn't look like the full image to me. The so the bottom and the heart on top, and also the double cluster on the upper right. So this is about a 8-degree wide field of view. And it was about 6 high, looks like about 5 high here. Star forming regions. A lot going on there in the core of the Heart Nebula. It's a little bit, this is, well, let's see now, if you could turn up the gain and look at it, it would look sort of like this, but not quite. It's done from hydrogen emission, which is the pretty red color, and from emission from oxygen 3, which is a teal color, red or green and blue. So when you mix them all together, you get a full color image of red, green, and blue. But then I did another technique on this where I ran it through a routine that's called StarNet, and removed the stars and reduced the intensity of the stars and added them back in at about 50%. So it kind of has a reduced influence of the stars so you can better see all the nebulosity around in the field of view. So that was fun. Took a couple of nights from my backyard, actually my next door neighbor's backyard, and she was willing to let me set up there and leave the telescope set up for several nights. Here's another image taken from Boulder. So StarNet allows you to take stars out of an image. So I decided, well, what happens if I take an image that I have of the Milky Way and take the stars out? And this is what happens. So this is a huge field of view. This was taken with a 50 millimeter focal length lens. So it's about 35 degrees wide. And it's centered on the constellation of Cygnus. And in Cygnus, you can the brightest nebula you can see in the middle is the North America Nebula. And then over to the left is the Veil Nebula that shows up in both the hydrogen wavelength and the oxygen wavelength very nicely. So that was a supernova that blew up 10,000 to 20,000 years ago. But in removing all the stars from this field of view, it looks to me like there was a lot of cataclysmic activity in the middle of Cygnus sometime long before the Veil Nebula, 100,000 years ago, to create all of that fine hydrogen structure that seems to look like shock fronts headed out from the middle of the constellation. And that was taken from Boulder, again, from my driveway, but using the narrowband hydrogen alpha and oxygen 3 filters, you can kind of punch through the severe light pollution in order to pick up details like this.
Looks like you got the Crescent Nebula in there too.
The Crescent's pretty bright, sort of left center in the bottom.
Right.
Yeah.
So what are
Nice.
those two stars off to the right? Could that be Jupiter and Saturn, which aren't stars?
Those are actually have some physical extent to them. And so I think they're tiny reflection nebula that the star removal routine can't get rid of. And so they actually have some size to them.
Hey, David, this is Mark. So what were you using for that?
Thank you, Mark. Sigma Art 50 millimeter lens.
Okay.
With an ASI 6200 monochrome camera.
Yeah.
And then I have it set up so I can put narrowband filters in between that lens and the camera.
Wow. Really nice.
So it was Mark who said, there's this great lens out there from Sigma. You ought to look into this. And I did, and I got one, and that's what I used for this image.
Very nice.
Turned out great.
Good stuff. I can't remember who's next. Hold on. Judy.
Okay. That was the first night that we got pictures of it.
Oh, wow.
May. It was when the balloon launch was. When was that? George, when was the balloon launch? I don't either, but early June, maybe. So it was in the morning sky. 4 o'clock in the morning. I don't do 4 o'clock in the morning.
Well, you did great here.
Whoa. That got really big.
Yeah. Well, I wanted to fill up the screen.
Oh. That's Aurora from 2018 in Two Rivers, Alaska. You couldn't really see it with your eyes as much as the camera could. So it's a fairly long exposure. And that was the first time we went out to Kathy Axton's gate.
That was Mars, I think, from 2 years ago, this image.
Yeah.
We first went out there.
Yeah, that sounds right. And that was last year, I think. I don't know. I think that was from this year. August, maybe.
I don't remember seeing any dates on these, but I should have included them if I'd seen them. Sorry.
Yeah, I don't think I had dates on them. I'm just trying to remember which file I pulled them from.
think
And I've
that's
got a
all.
perfectly good picture of Jupiter and its moons, and I can't find it.
Oh, no.
I spent the afternoon looking for it. I can't find it.
So these are mine. I've been taking, from my vantage point, we look straight to the east. And I've done these plane trails. I've showed you several over the past few months. And if you use your imagination, or if you know the outlines of those constellations, you can see Orion rising here. And with the plane trails. So I didn't, I'm just showing you some new images, not my favorites from 2020. But we, of course, get the great sunrise, and with the clouds lit up on this one, it was something sort of spectacular, I thought. It's just so smooth that I thought it would be good to grab. Nobody's shown any Gemini pictures, which I'm very surprised. This one's a time lapse over that tree, and it got lit up, and I didn't go edit those images out. But this was taken between about 10 o'clock and about 11:30 before my camera decided to die with, I was planning on leaving it open longer, but you can see several shooting stars in this. And then I took all those shooting stars that were in that image and created this composite. I heard from some other people that had I been out later, they were counting 40 meteors in about an hour and a half. This was, again, taken in about an hour and a half before midnight. And in this image, right down by my name, is Castor and Pollux, Gemini. So these aren't really lined up to radiate from Gemini, but still kind of a cool pic. And then this is a larger view of that star trails over that. I was kind of doing trying to catch meteors and also put it up over that tree. So it would, if you're going to have a Christmas tree, what better one to have than this?
John?
Yes, sir.
Was this Sunday night a week ago?
This was Monday night. Yeah, Monday night a week ago.
Because Sunday night was supposed to be the peak, and it was really cloudy down here.
Maybe it was Sunday night.
Yeah. Sunday
I do know that I went out at about 9:30, and it was clear, and then it quickly, this cloud formed right over the house. And that's the leftover in the lower right-hand corner. It eventually moved off to the northeast, but it sat for a long time, and I went back out at about 10:30 and then let it go, and it died about midnight, it seems. So the batteries died about midnight. So I didn't unfortunately, I didn't get the after midnight as we rolled into the constellation. So kind of a bummer.
One thing that pops in my mind, and maybe it's a little stupid, but David, Judy, John, you don't know what you got until you get these images later or something. You must be surprised at what you actually captured there. What's that feel like?
I'll let somebody else answer that. What do you think?
What?
I mean, I have an opinion.
And David probably
it's
knows
thrilling.
what he's capturing. No, go ahead.
You can monitor individual images, and so you stack, say, 4 dozen of them or something like that. Your signal to noise in the final result is better than what you see on the individual image. But say, for example, for the heart and soul, you can see the heart and soul, and you know that you've got them where you want in the frame. And one thing that's a little different is I'm taking these narrow band images in the light of hydrogen, and then I'll do that for one night, and then the next night I'll go back and do oxygen. So you're only seeing black and white interpretations of from each of those atomic species. So you don't really know how the color is going to blend when you're all done. But you can tell you've got it.
What were you going to say, Judy?
Mine usually look better on the camera than they do on the computer.
Yeah.
Why is that?
What happens on the computer?
It blows up the flaws.
Yeah, there's so many times when I've had a picture that looked great on the camera and I get it into the computer and it'll be slightly out of focus. I'm like, dang.
Yeah.
Yeah. One
That
thing,
happens.
John, before you move on to the next slide, I just want to, I don't have a picture to show, but for the Geminids, which, Leonard, we would love to send out emails to people, hey, there's a meteor shower, but we've been disappointed so many times and we don't want people staying up till 2 in the morning to look for them and see nothing. I mean, this is on clear nights, sometimes without the moon. But what I wanted to share was I had the most amazing experience with the Geminids, which, I was up late. I think I had a nap earlier, but I was up at 5:30 a.m. and I hadn't really looked out there much, and I should have. I probably would have seen a bunch of them. But I went over to the window, and within about 30 seconds, I saw the most amazing fireball or bolide, big, awesome shooting star that I've ever seen. And it went like a fifth of the sky it was way up high, straight down, solid white line, and then a big white explosion with blue and green on one side, edge of one side. And I've looked through a whole bunch on Google Images, trying to see if somebody else got a picture of it. But it just was so spectacular. And I just feel, like so fortunate to have just walked up to the window and seen that. And Leonard was about to get up. I went, God, you got to get up. You won't believe what I just saw. And we saw a couple other little ones, but it just was so amazing. And I didn't have to spend 3 hours out there watching. It was so special.
Actually, I think this year's display was one of the best I've seen.
Yeah. It seems like that. Yeah.
And a lot of it could be because this was, right with the new moon. So, I mean, it couldn't have been more perfect.
That's it.
Yeah.
Yeah.
And it was right near Orion, and Orion's my favorite.
You know where you're supposed to look.
Yeah, and I knew where to look. But anyway. Okay, John, back to you.
Well, I was going to say a lot of the pictures I've seen of the Geminids this year have been this greenish. None of mine I didn't see, but had green, but a lot of them have. And I wish I was supposed to go down to Chile for the eclipse on Monday, the total solar eclipse. I was planned and everything. And then, of course, COVID came along. And I'm so sorry that I wouldn't have been able to provide you pictures anyway, because it got rained out where we were going. So sad. We were going to go to Villarica, however you pronounce it.
John?
Yes, sir.
I looked at there was a YouTube video of the shadow going across South America, and it looked like 3/4 of the land area had clouds overhead.
The only pictures I've seen of the eclipse, and they're pretty good. There's still some high clouds in them. We're in eastern Argentina, right? And which was tough because that happened right at sunset for them. There's still some of the pictures I've seen have still been beautiful. There's a group of prominences in it was the upper left image. It might be in the southern part of the sun because of the way telescopes turn stuff upside down. But the corona was a beautiful thing. And then these prominences, the sun's becoming active again after its slumber. So we're ramping up now with sunspot numbers, which is kind of an indication of the activity of the sun. And the next peak will be in 2025, 2026, in 5 or 6 years. So more stuff to come in that area. So John, did you want to talk about the conjunction tomorrow night? Wasn't it John that wanted to do this?
Yeah, that's why I saw it.
Oh no, it was Dave.
Yeah,
You're right, Dave.
because I think Dave sent us this picture, maybe. Yeah, yeah.
It's from NASA, but I'm not sure exactly who sent it. You know, I found it on Facebook, but it's really well done.
Yeah, beautiful.
So this is the view tomorrow night. If you've got telescope in that field of view, and if you have good enough, you know, the Galilean moons around Jupiter, that's going to be the configuration. And then also probably only be able to see Titan tomorrow night. I don't know. We'll see. What else did you want to say about it?
So we're about 15 degrees above the horizon, so we're going to have to be on top of things to get some shots.
So right as it turns dark, we were looking tonight, but there were clouds, and I think it must have been above that. So people should look just as it's getting dark tomorrow, if it's clear. And is it west or southwest?
It's kind of a little bit southwest. It seems like around 5:15 maybe tomorrow evening. It'll be dark enough because the sun sets at what, about almost 4:40? Something like that.
It's 4:40.
So Dave, you're going to be taking some photos?
I'm going to take some telephoto shots. I don't have a telescope, but I'll do, I don't know, 500 millimeter telephoto shots. So I want to do a composition, you know, with some trees, maybe even kind of over John's house. I'll get Mount Thornton. I think, if I'm guessing where it's going to be, that would be included in the shot.
Maybe so if I'm up on my roof, you'll see.
Yeah, when there's something, you know, some kind of foreground thing to include in the photo. So I'll try that, and I'll try some something from you know, a little bit further away to see if we can get them closer together for the looking like one image, you know, like one star. Kind of play with the settings to see if I can do that too, because a lot of people would get a kick out of that. It's almost like, you know, being out of focus, whatever, but to have such poor vision that it all looks like one.
Well, if you overexposed it, it'll become one. Hey, John, I'm sorry, I didn't mean to interrupt you.
I was just gonna say, Dave, the Wednesday night shot that I shot close to 5:30, but I took some at 5:15, but the sky was brighter. I think in this case, the earlier the better, because a couple days, you know, pass and the two planets get a little closer to the sun.
Right.
You know, between 5:15. But I'm gonna try to get shots earlier when it's higher up, like maybe 3 o'clock if I can find Jupiter.
I've actually seen, well, the plus side of that, taking those pictures earlier with more sky brightness is less contrast, so that you can get you should be able to get a better picture of both Jupiter and Saturn together.
Yeah, if it's really clear out, they should show up fairly good right when the sun is going down.
Is this the view in the sky or a view through a telescope?
Telescope.
So
it's what
upside down from how it would look through binoculars.
I think this is the normal right side up view.
Oh, not a telescopic view. Okay.
Well, it's not inverted. It's the north is up.
Okay.
I mean, if it hasn't happened yet, it can't be a picture.
No, this is from like Starry Night or some such, or whatever NASA uses.
Right. So
this is not. It's a graphic. You're right.
A graphic, yeah.
I guess.
Educational.
So.
Here we go.
I decided to not cover what happened in 2020 and what's going to happen. There was so much going on in the past couple weeks or so that I decided to go ahead and just focus on what's going to happen. And so since this grand conjunction is happening tomorrow, there's a story that came out 2 days ago about these scientists who discovered a cuneiform tablet, a clay tablet from Samaria from 185 BC that appears to describe this, what's called the grand conjunction, not just a great conjunction, but it was 5 planets in the sky all together. And I imagine in 185, that would have been quite the spectacle, right? These were all within the grand conjunction and the great conjunction. They call them that because the planets are within 10 degrees of each other. Tomorrow night, Jupiter and Saturn will be within 6 arc minutes of each other, which is like holding a dime out at your arm's length. That's how close together they'll be. So they're pretty close. I mean, the closest they've been since 1280, some 1288 or whatever. But I got to looking at other notable grand conjunctions. Like I kind of got stuck down this rabbit hole. And of course, Kepler was looking back. He wanted to try to find the star of Bethlehem. And it turns out that in 7 BC, there was a close conjunction, a great conjunction between Jupiter and Saturn. Then they actually called it a triple conjunction. Right now, this Jupiter and Saturn are approaching what's called opposition. And that's why they're close to the sun. And so actually, a triple conjunction it happens within a year. It'll happen like 3 times because of our angle, Jupiter and Saturn's angle, and the rotation, stuff like that. In 2020, we're within 6.1 arc minutes of each, the 2 planets together. In 7541, there's going to be a, yeah, it's like February 16th, maybe plus or minus 5 months or something.
Put on my calendar.
Yeah, exactly. The last time, but this is what's going to happen in 7541 is that according to some models, Jupiter is going to completely obscure Saturn. It's going to occult Saturn. This requires a separation of less than 0.4 arc minutes. So it's just the tiniest little sliver. It's the last time that happened was in 6857 BC. So this is kind of a rare thing. Anyway, I just thought it was cool to throw it out there. Elsewhere in the news yesterday, in the Guardian, Britain's newspaper, they reported, this is the park dish down in Australia, and they reportedly got a signal from Proxima Centauri. Now, this signal, it's not tied to Earth because it's got some Doppler shift to it. And so they know it's not earthbound. So it could be a satellite. There's 2,500 satellites in orbit. Seth Shostak, who works for the SETI Institute, he's like the main scientist there. He was talking about that, one, it could be these satellites. It could be a microwave. This telescope, actually 5 years ago, they reported a signal that turned out to be a microwave on premises, creating radio noise that was, so we don't know if it signals from extraterrestrials, but it, this was in the paper yesterday, if you saw it, and I thought that was kind of cool. This is the Eye of Sauron. No, it's not really the Eye of Sauron. It's the National Solar Observatory this week, last week. It's a sunspot. And it was released with a paper that came out this month. So we just released this image of, this is the highest resolution sunspot image ever taken, supposedly. And Earth could fit inside the image. It's a little larger than that sunspot, but a lot of sunspots tend to be larger than the Earth. So stay tuned. There's going to be more as, the sunspots increase in number and size and intensity. So that'll be cool.
So John, was that the one a couple weeks ago?
Yeah, it was 2 weeks ago, yes, tomorrow we released that image. If you remember back in January, we released the first image of granulation of the sun. That was the highest resolution image. But this was not the sunspot that the NSO predicted that came around the limb after Thanksgiving. This image was taken in January last year, but we just released it. We just released it this past couple weeks. We being the National Solar Observatory. Sorry, I work for the National Solar Observatory.
What's the scale of this photo?
10,000 kilometers across. So the Earth would fit in it, just not inside this. The Earth is a little larger than the sunspot shown here. So 100 Earths can fit across the entire disk of the sun. 1 million Earths can fit inside it, but that's the resolution here. And it's been sharpened a bit, but not too much. This is even before adaptive optics have been this is from the Uae Solar Telescope in Hawaii. And they haven't even, this image wasn't even taken with the adaptive optics to make it even sharper, to bend the mirror slightly to adjust for atmospheric disturbance. So we think that we'll see even better stuff in the future. Open.
As I understand it, this was taken with the adaptive optics context camera, not any of the science cameras on the Uae Solar Telescope. And
well, David's probably right. He's closer to it than I am.
And so the adaptive optics was running.
Okay.
But this image was probably speaking out of cue, but since I've retired, I could do that. The director of the telescope didn't want any images from the adaptive optics being released because it's not the science instrument. He wants to have the adaptive optics fix the solar images, and then the ones that the world sees are from the science instruments that benefit from the adaptive optics system. And there's a good reason for that you really don't want to have your information from the adaptive optics system being siphoned off for other purposes, and you're not doing what it's supposed to do, which is to fix the solar image. But too many people saw this image, and therefore it had to be released.
Yeah, there's the politics surrounding this image are even weirder than that.
Yeah.
Anyway, but still impressive super image that we released. I just wanted to show it to y'all because it was the past couple weeks. This is one of the latest images from Hubble, and it shows this is Neptune, and Neptune has this dark vortex. Then Hubble's been doing a lot more planetary stuff. They've been doing a lot of other stuff too, but when they first noticed this vortex about 6 months ago, from what I understand, it was one vortex, and now there's the second one over there. I don't know the size. I mean, that's obvious. The size of this storm is about the size of the Atlantic Ocean. So it's about that width, supposedly. Cool image, if you check that out. And then, of course, one of the latest images from Hubble. It wasn't taken, they just released it recently, but this is an example of what's called an Einstein Ring. And that bright object in the center is probably a quasar with a lot of gravity. And what we're seeing, that curve to the left and the right, is actually a galaxy that's on the other side of this quasar, the light being bent by gravity. So we're seeing what's beyond the quasar. And Einstein predicted these rings back, in the day. And of course, it takes Hubble to, we're looking really, really, really deep into the universe here. So I just think this is a super beautiful. What's funny about this image, it was taken in the constellation Furnace, and they're calling this the molten image. Get it? silly. These astronomers and their funny stories. Anyway. That's all I got.
Well, thank you, John.
Questions? If you have questions, let me know, or I'll try to answer. Thanks. I can hear all the silent applause.
Yeah, the silent clapping. Do we have any other astrophotographers who had anything to share that haven't shared them already?
I forgot to ask anybody. Yeah.
Yeah.
Anybody got?
Well, I got a snapshot of the sunspot a couple weeks ago, but I can load it up next meeting.
That'd be great. Good. And then, yeah, anybody who takes the pictures tomorrow of the grand conjunction, yeah, please share those next time. And John, are you okay with them sending those to you?
Mm-hmm. Of course.
Or they can share screen. Then well, I wanted.
Either way, I don't care.
What?
Either way, I don't care. Sorry, didn't mean
to. I wanted Clark Chapman to share with us a little bit about this new movie called Greenland, which is apparently about an asteroid impact with Earth. Could you say a few words? Because I know that, Clark, that you and some of the other asteroid experts have been discussing this movie. We haven't seen it yet, but have you seen it? And then,
yeah.
And maybe
Greenland was released just a couple days ago, and it's widely available on pay-per-view and streaming and so on. Okay. And what it's about is it's about supposedly an interstellar comet larger than the object that killed the dinosaurs and everything else 66 million years ago. And it's a drama, and people might like the movie as a drama. It involves a family, and it has a whole lot of people panicked. A very tiny fraction of the population has been selected to go to bunkers underground in Greenland to try to survive, something bigger than the KT boundary total catastrophe. But I, of course, looked at it from its astronomical perspective. And despite the fact that there's an interview or an article based on an interview with the director in space.com that says that he did all kinds of research about comets, and he talked to people at JPL and so on. It is just complete rubbish scientifically. It's just terrible. It's just hard to believe. There's a little bit of a description at the beginning of the film about the difference between asteroids and comets, which is very roughly right, a few sentences worth. But everything that happens, I mean, it's very spectacular to watch. There's just all kinds, one of the first things that happens is some fragment of this comet basically destroys the city of Tampa, Florida. But throughout the movie, it's as though millions of things strike the Earth in the course of 2 or 3 days, of all sizes, including tiny little things, like if a ping pong ball were to come zooming through the atmosphere, fiery, and hit the ground, which doesn't happen. I mean, we all know meteorites, fist-sized meteorites, are slowed down in the atmosphere, and they basically land cold. Everything is wrong about the science. It's a pretty exciting movie to watch, but I just don't know what happened with this director who claims he researched comets and he talked to people at JPL. And anyway, as a scientist, I'm offended Deep Impact was a much better movie back 23 years ago or whenever it was. But if you watch it, just realize that everything that goes on is in the sky is just completely wrong.
Clark,
Okay.
you've watched these shows. I mean, they do have an impact, as you mentioned, on the public. And, so what's the takeaway message here? Was there anything good about them? I haven't seen it, so I don't know.
Right.
Well,
what worries me is people like myself and others interested in asteroid impacts and so on, have been trying over the last 2 or 3 decades to educate people about the very basics of how astronomers track asteroids and comets in the sky, and how predictions are made about the chances of something hitting the Earth, and if it were to hit the Earth, where it might hit the Earth. And this just tears it all to shreds. At one point early in the movie, it says that this comet, and this, by the way, the comet is named Comet Clark.
Oh no! Oh no!
No wonder.
Although it's Clark with an E, and I don't have an E. But
That's started wrong right there.
but there actually is a professor, Chip Clark, first name is actually Lee Clark, at Rutgers University. He's a professor of sociology, and he has, for decades, he's written books on how panic in the public as a result of natural disasters is just a fiction of the news media. People in natural disasters actually don't panic almost ever, according to professional sociological studies. So, but his name is Clark, spelled with an E. I've corresponded just a little bit with him in the last couple of days, and he's very happy that this comet is named Clark with an E. But at the beginning of the movie, it says that this comet, which is very big and bright, it's a daylight comet. I don't know if you know, but back in 1910, there was a daylight comet, and it wasn't Halley's comet that happened in the same year. It was another comet that was actually visible in the daylight. And so Comet Clark was visible in the daylight, and obviously astronomers would have been tracking it for a long time. And it originally says that it's predicted to miss the Earth. But a couple of days later, it mysteriously fragments for reasons I can't imagine. And one of the fragments hits, as I say, Tampa. And by the end of the movie, Europe is destroyed by something bigger than Chicxulub. And it, that's something as big and bright as Comet Clark. We know exactly where it's going and when it's going to hit, and so on. And so it, in answer to Leonard's question, it just seems to me it completely destroys the story we've been trying to tell about how it's actually possible to observe these things, comets and asteroids, and predict where they're going to go. When you get more and more observations and you narrow things down, and it's just fiction that it would be predicted to miss the Earth, and then a little later it's predicted to hit in the Atlantic Ocean, and then Tampa is destroyed.
Okay, to that point though, and I'll shut up. You were involved in the Apophis Workshop. That's a real-time worry. Well, I want Clark to explain Apophis, but we got other people want to talk, but that Apophis Workshop was fairly significant.
Well, Apophis is this pretty big near-Earth asteroid that back in 2004, when observations had come in over the course of a few months, and it was predicted to have a chance of like 1 in 20 of striking the Earth in 2028. It happened to be overshadowed by the fact that a real natural disaster happened, which was the Indian Ocean tsunami, like 2 days after this prediction came out, and it was on Christmas or the day after Christmas. And so people kind of forgot about Apophis, except the astronomers didn't. But a little later, more observations came in, and it's clear it's going to miss the Earth on, I think it's April 13th, 2028, but it's going to come damn close. It comes underneath the geostationary satellites. It's going to be naked eye visible if you're over on the other side of the Atlantic. You know, it's like a second magnitude star zooming across the skies. So it's coming real close in 2028, but it's absolutely not going to hit.
Also, hey, Stephen Langmuir, can you give us a little update on Dream Chaser and what's happening where you're working?
Sure, yeah. Can you hear me okay?
Yeah, I think so.
Okay. Well, let's see. We recently got permission to proceed with Tail 2, which is great.
You might want to explain Dream Chaser for anyone who doesn't know what it is. Okay.
The current cargo version of the Dream Chaser is a cut down robotic version of a space shuttle. We lost the contract for manned space shuttles, so now we're building a much smaller robotic cargo ship, and we have a contract to do 6 resupply missions to the International Space Station. And we recently got the go-ahead to begin a second vehicle, or Tail 2. So we're going to have more than one. Also, we successfully grew some radishes a couple weeks ago on the International Space Station. So Mark Watney would be really happy to have our veggie unit, you know, sitting there spinning, and instead of eating potatoes and nothing, you know, nothing coffee, just like hot water with nothing. You know, he could like spice things up with maybe some teas or some herbs or something. You know, we've grown tomatoes up there, lettuce, that sort of stuff. So, yeah, that's what's happened the last couple of weeks. Oh, and Janet Cavindi is my new boss now, in charge of SSG. She got promoted up. I don't know if you are familiar with Janet Cavindi at all, but she used to work for NASA. So anyway, that's what's happened so far in the last couple of weeks.
Hold on to your desk.
Yeah. That's great. Yeah. And we missed you, having your daughter with us, you know, who was coming to a lot of our in-person meetings, and hope she's doing well. And if Skywatchers can help any kids who are, you know, with projects at home, or if they're back in the classroom, we have experts who would always love to help kids.
Great.
Their projects.
Yeah.
And Michael Carroll, Mikey, do you want to say a few more words about your book, or do you have other online talks coming up for, you know, there may have been a few people who missed your talk on Skywatchers on exoplanets.
Yeah, well, I have a radio interview coming up on Michio Kazu's show, and I don't know when it's going to be, so sorry about that. But I also have a question for Leonard about Perseverance, and that is, these rocks that they're gathering on Mars, do they have any hardware to transfer them to something?
Transfer them to something. They're going to put them in tubes, you know, the samples. I mean, the way this is going to work.
Yeah.
So
if I listen to all the NASA PR.
Okay, so just to review, though,
Perseverance is en route to Mars. It's going to land in February.
NASA.
This is the NASA. This is Curiosity
rover.
Like, but super important in the sense of gathering samples on Mars to be picked up later by a Mars return sample
That isn't
spacecraft
funded.
mission.
That isn't funded.
Well, I don't know if it's not funded. I don't know. Anyway, that's details.
Yeah.
Anyway, yeah, no, that it's going to collect these samples. You know this, and then put them in little tubes. You know, if this thing's going to land in Jezero crater, which has a high probability of being an enclave of, you know, past life that they can sample. So they're going to go dig around in there and
so negative.
well, I'm negative. I'm not happy with this mission for a lot of reasons. Anyway, so it's going to go down there and put these like 22 or 30 tubes of material that they'll collect by the Perseverance rover. And this is the first leg, in quotes, of the Mars Return Sample Program, which is in a very elaborate, I think it's about 8 billion minimum to go collect those samples and bring them back to Earth. That's another story. We'll get into that later in some other forum. But anyway, you know, so it's part of the, you know, NASA is responding to what, you know, that a decadal plan has always, you know, put forward is like return sample from Mars is a big holy grail. NASA has been after this for a decade or more, bringing back samples from Mars robotically. So this is the first leg of this damn thing. Now, I will say, in the story coming up, I will ask somebody very important, if this damn thing crashes, where does the return sample program go? Well, there is no plan. They think this thing is going to work. And believe me, as somebody, you know, I'm always Mr. Negative. Nobody, you know, nobody wants to hear me be negative here. But, you know, the things crash on Mars, I've been told. And, you know, if we're, you know, I'm sorry, Michael. I'm going overboard here. You know, I've been there when things fail, and we've got too much riding on this damn thing not to have a backup plan, and I'm not sure we have one. So, and if it, yeah, and I'll be the first one to go, it's so great how wonderful it went. You know,
if it does.
You know, but you know, the whole Perseverance rover thing is so cool. And let me go on to this. We're going to have video, live video of the thing coming down and parachutes unveiling.
Whoever Lena is needs to mute, please.
Wait. John, you probably have to mute.
People are upset. I don't know.
No. John, you probably have to mute Lena.
So
is Lena on there?
Yeah.
I
But
gave you.
She's from Washington, D.C.
I gave. Shoot. Can you get me back hosting?
Yeah.
Can you make me host again?
Oh.
Barb, can you make me host again? You can do it.
Jeez. How do I do that? I didn't know I was host.
Yeah.
Okay, wait a minute.
I gave it away.
What do I click on?
Michael, what do you think? I mean, you know,
maybe
you know how important this particular NASA Mars landing is. What do you think?
Well, my concern is that there isn't a plan beyond it. I mean, you've got a pile of samples in a basket. How are you going to get that stuff into a high technology ascent vehicle?
They're not in a basket. That's the problem. They're not in a basket. What they've chosen to do is to leave them as breadcrumbs along the way. So every time it takes a sample, it drops it on the ground. And another rover has to come along and duplicate the entire path and pick them all up. It's even worse than you thought.
Oh, that's good. Yeah. Oh, okay. I'm pretty excited.
I'm at a point where this sounds heretical, but I mean, I'd almost give this to the human mission to Mars. The return sample, you got to look at the value of the return sample. This is supposed to flight qualify humans to go to Mars. That's not going to happen. Those samples will not tell you whether or not, humans are going to survive on Mars. And I'm not sure how it fits into the big queue about,
come on, Leonard. I mean, that's not fair. I mean, with the moon, you can start to press in on the possible what humans will do. Like, why should we do a South Pole sample return from the moon, which has been identified as a high priority? Why should we do that if humans make it by, say, 2028 even? Okay, but Mars, I mean, let Elon Musk do what he wants to do. But I mean, Mars is still a scientific object, and there's no guarantee humans will ever get there. So I think it's unfair to try to express our Mars science program in terms of what people might possibly do one day.
Yeah, well, I'm more optimistic. I think humans are going to get to Mars. They'll probably, I actually sent Elon Musk a note and said, boots on Mars. All I want is them to land an unmanned capsule and eject boots. And and just throw out boots. And then we'll say, we got boots on Mars.
The Mars sample return has been a holy grail scientifically forever. I was on a National Academy of Sciences committee concerning the solar system back in the late 70s. And it came out with the most important goal in planetary science in like 1977 was to return a sample from Mars. So it's been going on forever, and they just, since it was number one back in the 70s, they never want to just sort of cancel it and make it all go away.
And since the more formal process of the decadal surveys has come up, it's been ranked number 1 or number 2 in the last 2 decadal surveys. And there's a planetary science decadal survey ongoing now, and it's going to be very interesting to see, how the scientists decide on Mars sample return. It's inconceivable they'll just say this has been too long. We want to do something else.
Yeah, and you're going to have, to the expense of Venus, Enceladus, Titan. You're gonna erode the entire outer planet budgets. There's no money. There's no money. It's $8 billion minimum for that damn thing. It's not, it's going to erode the entire solar system.
So what just happened? I must have stepped away. How did this come up? Because didn't the Europeans just announce something about their ascent vehicle, that they were having a mass problem, and there was some aspect of the mission had been redesigned?
Yeah, well, I'm sure that's the beginning.
Right.
It's more than $8 billion for this return sample from Mars. It's going to take away the entire solar system.
It'll be 20 billion before it's over.
I'm sorry. I've had too much wine. Never mind.
Well, here's
I gotta go now.
Wait.
Okay.
Bob was saying something.
Yeah, I mean, the thing you got to realize also is that Mars is the only planet that has its own program. All the other planets have to live in the solar system. Mars gets to be by itself in NASA headquarters and at JPL. And so, this is a jobs program. They need to keep going to Mars because we've gone to Mars and because we can go to Mars. So, trying to get science done in the meantime is what everybody else is trying to do.
That's a good quote.
I always say Mars is first among equals. That's my quote. Mars is first among equals. I love Mars, right? But it's just always there with the sample return, just like you said.
Hey, Leonard, you might just think about the fact that China might send something up there and bring back samples pretty fast.
Exactly. I didn't even get to that. No, that's right.
Yeah.
They have their own return sample. In fact, one thing I didn't say, that China lunar landing program mimicked what they want to do at Mars. It did everything they want to do at Mars. And they can do their own return sample program. So
And
I
they
don't know.
telegraphed that to the world. We know that. So that might just be the kick in the butt that we have to do to say, okay, let's go get our samples.
It worked the other way. Yeah, I'm with you. Yeah, there's something wrong here. I can't figure it out myself, and I love Mars. I want us to explore Mars. I think it's got some surprises still, and let's get on with it. But man, the way we got this thing structured is not the way I would, I'm just a reporter. I listen to all these people and they won't even let me quote them.
Yeah. Oh, that's
Yeah,
right.
Leonard, back in the Case for Mars days, we'd have had all this done 20 years ago.
We would have done it.
Oh, yeah.
That's right. We would have done it. Yeah, move on. We've discovered life on Mars already, I'm sure. And now we're going to rediscover it. So we'll see. Anyway.
Well, all we have to do is keep buying Chinese stuff and they'll be doing it for us then.
Buy American, buy local.
Yeah, buy local.
Well, then China won't do it if we buy local.
Yeah.
True.
No, but I think there really
China.
is.
Wait,
okay, never mind. Shut up.
No. Just somebody else was trying to say.
Okay,
don't underestimate China.
Yeah, I think there's really kind of a, the life on Mars question, I think, is really a little bit of a race because you do have the other one that's kind of an outlier here is the European Space Agency with ExoMars. If they get down on the surface, Bob's shaking his head no. It's not going to drill deep enough.
No, they're going to go 2 meters. 2 meters. It's like, they have said like, okay, 1 meter is how far the radiation goes. 2 meters is how far the oxidation goes. So we're going to go 2 meters and we're going to find life. They need to have their own science and technology and it's great.
Yeah.
But, 2 meters is not going to tell you anything.
Okay. So what I'm working on now is kind of a look at, I'm not going to tell you too much, but there's a bunch of things going on with low-cost missions to get to the guru here. Can we send something to Mars that's going to close the loop on this thing? Do we have to drill down? Do we have to dig into caves? Do we have to go to the polar caps? What is it that we got to do to close the loop on this life on Mars thing? I'm sick of it.
You asking me?
People.
I'm sick of the life on Mars question. Let's get on with it.
Right. So the problem is that we can't ever do enough at once, right? Robotic missions can't do very much. And, they can analyze certain chemicals in place. We need boots on the ground. Like, let's go to a lot of places and get a lot of stuff. And then we can see if there was past life on Mars. If there's life on Mars today, it's probably down really deep where there's water. And although we have ways of finding where there's water, real water, deep, we'll never get to it. So it's probably moot unless it gets erupted out somewhere. So we need a lot more. How could you, I guess Earth has got life everywhere, but the idea it's a whole planet. We're just going to they're going to land the best place. They're going to look for the, evidence of stuff preserved in sediments, bring it back. That's the best we're going to do for until people are driving dune buggies all over Mars.
Yeah. Okay, Bob. Okay, one of the things that I'm trying to get to, if we can't get it right at Mars, what kind of audacity do we have to go to Europa and Enceladus and ask the same damn question?
Mars is harder than Europa.
Mars is harder
than Europa.
Okay. And harder than Enceladus.
Okay.
This stuff's shooting out into space. Right? You're gonna a whale could shoot out of a crack and we could find it. You don't have to. on Mars, they're talking about microorganisms in the past or in the deep subsurface today. On the ocean worlds, you're talking about stuff swimming around, deep under these ice shells. I mean, I think that even Culberson, when he was the congressman pushing Europa, he said he'd be happy if there was krill that were shot out of the tiny organisms, but they're complex, in the whole chain of life, and they're small enough that they could get shot out of a crack, and you could find that at the surface.
And we can package them and eat them.
Yeah.
Krill,
Mikey,
I think we could do
Mikey, Mikey, I want to see a whale shooting out of a crack of intel in your next painting, please.
Okay, you got it.
Thank you.
Yeah, this is a commission. We want to see this.
Artwork of that.
Okay, this whole thing is upending.
I think you've got another book there full of images. So Dewey, were you trying to say something a few
hours
minutes
ago?
Not that I know of.
Oh, okay. I thought I saw your lips.
Actually, I was going to say something to Clark. Clark, are you still part of NAS?
Yeah, I wasn't part of NAS in the 1970s. I mean, it's a committee. It was called Complex, and it was that committee is long gone and has been replaced by this process that Bob was talking about. And no, I'm not.
Well, the NAS has a science and entertainment exchange office in Los Angeles that perhaps scientists who are upset with stuff like this could give them a call and say, how did this thing get past any kind of review? Because it's there to give people information, to give producers information. It sounds like this producer didn't take it seriously.
Well, actually, my colleague Al Harris over in Pasadena actually wrote yesterday that he thinks he was actually contacted through the committee you're talking about, or the organization that you're talking about, and he wrote back and said that plot makes no sense, but if you do this, that, and the other thing, the movie will at least sort of pass muster scientifically. And he never heard back from anybody. So
I thought they just facilitated contact between producers and scientists.
Well, I guess they facilitated the contact with him. He wrote back to the director and never heard back, and the movie's
Boy, I wouldn't want to mess with Al Harris like that.
So does anyone else have anything? I mean, we could stay on for hours if you want. Usually we just go to 8. It's about 8:40. I have one other thing that I think came up in this last year, and that was the dimming of Betelgeuse, the top star in Orion.
Yeah.
And anybody have any, I guess it got brighter. It looks, I always look at it every night, so it didn't look like it was all that dim, but does anyone have any idea of why it went dim for a while and we thought it might explode? And I guess, should we worry? Anybody?
I'm pretty sure it's COVID related.
Okay.
Shh, you weren't supposed to tell anybody that.
Wait, back on the thing about finding the life on these different places. We actually don't have to worry about all those space missions because Leonard is going to put together here shortly. A group was going to tell us that the space aliens who are here already are going to eventually tell us where they move, where their life.
They invited many of them over last night.
Yeah.
It's a very confusing message. It's coming January. I think that Zoom thing is going to be in January.
With aliens?
Revelation.
Oh, with the UFO thing.
Yeah.
Yeah. He has to decide by tomorrow. No, we've got a week actually before the next Mountain Messengers. So I think he's going to try to do this UFO panel in January.
Yeah.
So probably, well, we have to see. He's trying to coordinate these 3 people on the panel. So, but if we can, we'll try to do it 4 weeks from tonight, months from tonight.
I really watched that Proxima Centauri thing with Pete Warden and the breakthrough, what is it, breakthrough technology or whatever it is.
Breakthrough Star.
What is it?
Breakthrough Star Shot.
Well, yeah, but they have a big, the big, yeah. But anyway,
Breakthrough listen.
Yeah, the breakthrough listen is the way.
Yes,
so something's going on there, and you know, these are, you know, frankly, the signal coming out of that is confusion, which shows you that we're not ready for any kind of clarified signal. You know, when even these people that are using, I think who mentioned it was Australia. You know, Pete Warden put out a message the other day. They're going through a protocol. They're trying to find other observatories to verify that signal that they got. So that's the protocol. And we'll see where this is going to go. But regardless, it shows you, you know, the kind of the tempo of confusion that we still are in if we have really a signal like the wow signal from years ago.
Yeah.
So it's actually a you know, kind of a seminal moment of confusion, but it could be important. It could be blasé. Michael, what do you think? Come on.
Well, yeah, I think we're sadly unprepared for anything like that confirmation, but we need to be thinking about it, you know, and now that we know that there's an possibly Earth-like planet in the habitable zone of Proxima, all of a sudden it's within shooting range. And that makes listening to that region much more important.
What changed? What is
range is interstellar travel.
Yeah, if you make some minor advancements in laser sail technology, we could have a probe there in 50 years.
What is new about this detection? Haven't we been looking at Proxima Centauri since the beginning of radio telescopes? Is it better resolution? Is it did they just get there yesterday? I mean, what's new?
Well, I think the only thing that's really new is the fact that we've located a likely planet in the right spot. So we have the motivation to put more resources in that direction. But you're right. I mean, we've been studying it for a long time. So
we've also been bombarding it with our signals for close to 100 years.
Yes, they know I Love Lucy very well.
Among other things, yeah.
Is there a new radio signal that's been detected, or has it just gotten interesting for some other reason?
I didn't see the Guardian piece. Did anybody?
Go to Scientific American. If you go on my Facebook,
link on it, I think.
Yeah, Scientific American has a pretty good article on that. It gives you a lot of perspective there. There's something amiss that doesn't quite gel up, you know, and Pete Warden is kind of going, you know, I don't want to say, you know, signature, you know, techno signatures. I'm just saying we can't figure this out, and it's a little odd. And there could be a lot of interference that we're not aware of. But I mean, he opens the door for, there's something there. There's something that we ought to be looking at. And again, if it's not a civilization, we need to have these false fronts to understand that we can pick these up, and then we discount, you know, other things we see. Anyway, there's something there.
Signal. It's a radio signal, and it's in archival data, which
yeah,
the sniff test that They didn't just start beaming it to us yesterday.
Whatever happened there, he's put out the signal to strength frequencies and trying to get some other observatories to dive in there and see if they can coordinate or figure it out. And so, but again, it's all false front store. It's great. I want all these wow signals, and we'll do our best to discount everything until we run out of limitations. It's great.
Well, according to Facebook, they've already talked to Donald Trump, and he wanted to tweet about it, but they dissuaded him because people would panic.
That's what I was.
That's on Facebook. That's on Facebook.
I know it's on Facebook.
Well, that's a primary source right there, Yeah, if you check Twitter,
Don't we all get all our news from Facebook?
Remember, people don't panic, according to the expert.
That's why I thought of it.
And remember, approximately half of America will discount anything that's tweeted on that account.
Hopefully.
We got to run, guys. It's good to see everybody.
Okay.
Yeah.
We got to go.
Okay, thank you.
We're out of
Thank you
here.
to all the astrophotographers. I really enjoyed the pictures.
Yeah. Thanks. There were 28 of us on here. That's kind of a record. So I guess you guys all did your Christmas shopping if you had to do that, or holiday shopping. And we'll be thinking of you, and hopefully sometime in the new year, we'll be back at the hall too.
Yeah.
And we'll try to keep doing a Zoom thing from there for people we brought in from the outside.
It works.
Merry Christmas.
Yeah. Anyone else have anything?
Everybody.
Yeah. Thanks so much. We love you all. Miss you so much.
Bye-bye.
Happy holidays, everybody.
Cheers. Thanks for everybody who contributed. Yeah. Buy Mikey's book. Except Envisioning Exoplanets is beautiful.
All right.
Good to see you, Dewey. We missed you the last couple times.
Yeah, I've been watching football.
Oh,
Sunday.
right. I checked. I actually asked, because Dave and Susie are into the Broncos, and I guess you are too. And I, on my phone before I got out of bed, I said to whatever, it's not Alexa, it's Siri or something. I said, what time is the Broncos game today? And it goes, there's no Broncos game. They're playing the Chargers in next week or something.
They played on Saturday this week.
They played yesterday.
Yeah, they did, and they lost. I saw that. Although I don't follow this stuff very much.
Yeah.
Really.
All right, well, see you in January then.
Yeah. So good to see you.
Dewey, are you going to be on at the Rocky Mountain Mars Society tomorrow?
Yeah, I should be.
Oh, cool.
And if the sky is clear, I'll just come in from looking at the conjunction. I'll set my telescope up in the back patio.
Yeah, I'm going to try to get some images through my telescope. Will be better than that one I showed, but it's going to probably not be very steady.
I held my camera up to the eyepiece and I got a picture that has a rounded dot and an oblong dot. So the round dot is Jupiter and the oblong dot is Saturn.
That's not easy to do. Get your camera lined up.
Yeah, especially when everything's black.
Yeah.
You're looking for the exit pupil of black amongst black. So.
Yep.
And the moon's easier.
All righty.
So okay, yeah. If you need to go ahead. But Mars Society, that's a Zoom meeting. You're doing, yeah. You're not getting together.
Mm-hmm.
And do we know why Robert Zubrin sold Pioneering Astronautics?
I didn't know.
Yeah.
He did?
I don't know.
Yeah, he sold it, didn't he? Or does he have some? Is he still running it, or?
Well, he is at least 65, so who knows?
He has about zero interaction with the Rocky Mountain Mars Society ever since we made this stuff for
Yeah,
F Mars.
I
and
thought he
Nebula.
maybe did.
So he doesn't really get involved with us, which I find puzzling since we're like his local chapter of his organization. So who knows? Bye.
So anyway, bye, Dewey.
Bye.
Good to see you. Happy
See ya.
holidays. Yeah. So we got George and George in the kitchen and Mark. Mark's still on here.
Yeah.
I think we lost Judy. Yeah, okay. Yeah, so I saw your cat. Did you see at one point Sam showed his dog Dewey. That was cute. Yeah. I've been talking to Sam some too, Sam and Sandra. Yeah, I'm sorry she wasn't on there, I guess.
I was incognito for a while because I had to make some food and didn't want to, have everyone be distracted by watching me eat.
I know, right? Really. Yeah. That sounds good. I'm just looking at what John Elmore left on the chat thing there. It was here December. Oh, okay. I think David Elmore was putting something on there from the scientist, I guess.
That's the article.
Oh, that's the article he said. Okay.
Proximus.
Oh, is it?
Well,
Okay.
I had a thought, Barb. A couple things we were talking about Proxima Centauri, and there's this thing that they're building called the Giant Magellan Telescope.
Yeah.
And there's already been papers out on what kind of biomolecules, biosignatures that will be able to detect around Proxima Centauri.
That's important.
You want to say
no,
something?
that's the next wave. It's
But
really,
see, that's only 10 years from now, probably.
Yeah.
But their progress has been slowed down because of the COVID thing, and the funding on all these big projects is getting interrupted temporarily, at least.
So where is that? South America?
Yeah, it's going to be in Chile. I don't know. It's in the tropical, or just I guess -30 or something. But yeah, it'll be right overhead for them practically. So yeah, there's a lot of stuff that's happening, and this Mars sample return thing, it just seems like a kludge to me. And who even knows if the new rover is going to land intact, because that landing system worked once, but it's really complicated.
Yeah. Yeah.
That's your thing.
Yeah. Yeah. No. Yeah. You don't want to get me going. No, the Proxima Centauri thing is, the biosignatures. I mean, that's where we're headed next, is these observatories that have much more capability that can, and I guess Jim Webb Space Telescope, if it ever gets out there, would be another one that would help on this. But we're going to fine tune this biosignature. But, as you go to meetings and people are arguing about what a biosignature would look like. I mean, what is it that, a techno civilization would eke out that we could guarantee that, oh, okay, they're down there?
Well,
What
a
is it?
visible laser beam would be pretty obvious.
Methane, they're farting.
They have
what is
cows.
it? What is the biosig? I've gone to too many conferences and I'm confused about what the signature would really, and you can see, even with Venus, the disagreement about what a biosignature might look like. That's probably a precursor of what we're going to get into with these exoplanets.
I'll tell you, this thing that Bob was talking about, this 12-place polynomial equation, figuring out where what that waveform should look like. Yeah, that's really complicated stuff. When you do like calculations in optics for figuring out the index of refraction at a very specific wavelength, you need to go like have all these terms in parentheses with, you know, to the 6th power, then to the 8th power, and then it goes out and out and out. And you have to basically make up a spreadsheet and go look to see that you entered everything just right, because that kind of stuff can really throw you off if you don't get that equation just right. And you can't do it on a calculator.
What is a slam dunk? I mean, we got to agree on what a slam dunk is. You know, what is it that you know, this is the ET signal. You know, I didn't want to get into it, but you know, this wow signal is being re-looked at. This Proxima star thing might have something, and we just, you know, there seems to be a built-in thing, and it's probably part of science, to discount ET, because they're going to try to find, you know, a whirling neutron star next to a galaxy that far, far away, and you know, there's some kind of mutation. You know, whatever it is, you know, they're going to come up with a lot of other hypotheses, and not the signal. And so what is the slam dunk? I don't even know what it is.
Well,
I don't want equations.
I don't either.
You can't do equations forever. You know, we got to find out what is it that is the one that people are going to agree that we found something. What is it?
You know, we were talking before about NASA people, I think it was, that were making kind of a big deal about the phosphine signature in Venus. Remember back in the 90s when people said we had Antarctic meteorites that were from Mars and they had fossils of bacteria? I think sometimes they just like to blow their own horn so they get, you know, more support or something.
There's some of that.
But you
I'm very familiar with that story.
Yeah.
He was interviewed by what, CNN or CBS or something on that particular meteorite when we were back in
ALH,
DC.
you know, 84001. Believe me, I was deep in that.
Yeah.
Yeah.
He kind of broke the story.
Yeah.
It was it New Scientist?
I don't want to go into it.
Yeah.
Yeah. Anyway, there's a lot in there, and you know, we just seem to always, you know, and I think that's science. I think it's a good thing. You know, you want to play it out, you know, as far as you can to discount the major discovery that somebody claims. And some of that, I'm worried. I'm still concerned about the, I don't know, what do you think? These, the signals that we're getting out of, what do they call those damn things?
Pulsars?
No, well, it started out with pulsars. You know, pulsars were discovered, and that was the little green men. You know, and then it wasn't little green men. It was turned out to be pulsars, and we came up with a theory about pulsars. Okay, now we have the what's the name of those GPHs, or you know, the grand, you know, the big things we're hearing that don't make sense. So we've come up with all kinds of theories about how they're created.
Oh yeah. The something radio bursts. They're somewhat repeating occasionally.
Yeah. And we're seeing those, and they've come up with new theories about how they can be created. And some of this, you know, I just hope we don't go down a rat hole and we miss a lot of signals that we're hearing, and we just come up with all kinds of theories about, you know, how you can imitate those things. And, you know, how do I know? I'm just a reporter. It seems like there's something wrong there.
So are you suggesting that we're trying maybe a lot of different things, but not sitting back and maybe trying to figure out a better strategy than going more seriously on that?
No, I think there are people that are serious about everything, and they're trying to come up with scenarios of why that shouldn't be a signal from an intelligent civilization. There's something I don't know. I'm telling you, I just feel like we're trying to come up with every mechanism to discount a potential wow signal. And maybe this new one is a wow signal. Some people are comparing it to that. And I just don't know if we're just, it seems like we're on the edge of a city trying to focus in the radio and picking up that FM station. It's just not coming in. There's something wrong here. And I don't know what it is. I guess I'm probably leaning toward we're going to make contact soon. It's going to happen. It's not contact, but we'll certainly pick up a signal that we can't discount, that everybody agrees that has got to be a civilization. Do we know what those boundaries are?
Yeah. I don't know. I mean, there's this optical SETI too that's looking for, like I said before, laser beams.
Laser pulse is fine.
Yeah.
But again, the SETI world is not going to be a one type alien. It's going to be, you could have laser pulses from some other civilization. You could have, leakage out of their radio transmissions or, radar or whatever they're doing. It's going to be, there's not one thing.
Right.
It can't be. If you believe that the universe is populated with a lot of intelligent life, there's not going to be one type signal. It's going to be a multitude of different kind of, here we are.
For sure.
And I don't know if we're ready for that. I don't know if we're doing the right job. I don't know. It's a mess, it's going to sort itself out really fast. Is what I think is going to happen.
Hope so.
I thought it was going to happen this year, and I'm still on track with 2020 if this Proxima Centauri thing. I wrote a story. I said this is the year of we're not alone.
Well, just think that Arecibo was beaming radar at asteroids for how many decades?
Yeah.
And where do those beams go? They go right out.
They go beyond the asteroid. They're out there.
Exactly.
Yeah.
So.
Look, there's something. I just feel like we're not there yet. We've got some kind of problem of accepting this contact thing, and again, I'm just a writer.
Well, you can't deny that tens of thousands of people, maybe 100,000 people every year, are seeing something strange in the sky. Whatever it is, they're seeing it.
Oh, so did you listen to Coast last night?
Not last night. Why? Who was on?
Oh, some guy who was talking about back in the 60s and so. Folks who would be going to drive-in theaters would be seeing actual saucer craft at the drive-in theaters hovering around.
Yeah.
I didn't know what to make of it, but I thought it was pretty. First time I ever heard anything like that.
Well, I've never seen anything quite like that, but a friend of mine was out in Utah, along the San Rafael Swell, which I think is in BLM land. It's near like Goblin Valley or something. And they're all on their way to the Grand Canyon. And this one of those big black triangles came in and hovered over them for a while.
Was that what's his name? With the 30-inch?
No. It's this was a guy that I know from where I used to work,
Okay.
Leonard saw one of those black triangles.
I've seen the black
in San
triangle.
Diego. Yeah.
Wow.
Yeah, I can tell you that that's the damnedest thing I've ever seen.
How big was it?
No, but you know,
How big was it? Yeah.
I could not tell. I mean, it was so.
It was copying stars above it.
Yeah, it was. Yeah, it was blocking out stars above it. I couldn't tell how big it was or how high it was. But
Did
I
it
can
do
tell
anything?
you, I saw something that was later confirmed by my friend at Aviation Week as a, you know, it's a classified military U.S. Craft that's a cargo ship that hauls a lot of shit from one way to the other. And why it's still classified, I saw that probably a decade ago. And I don't know why it's still classified. There's various versions of them. But, you know, people see that and they're going to go UFO.
Well,
you know, for me, it was just something that was clearly, you know, kind of a U.S. built deal.
Well, you know, this David Fravor from the Navy who saw the TikTok things.
Yeah.
Yeah. He said that a lot of times they were doing training out in the desert. And one time they got these, you know, infrared sensors and they saw a campfire down there in the desert at a campground. And they just idled their F-15 down and came straight towards the thing. And then at the last minute, put their landing lights on and put the afterburners on and freaked out the campers.
Yeah.
And that stuff kind of, he's saying that kind of stuff happens.
Oh, yeah. You know, yeah. Yeah, we got to pick and choose what we want here. But yeah, it's a very confused and, you know, construed story. We'll see. I just saw the CIA former director Brennan actually addressed this issue about UAPs. And he's seen all that Navy footage and he's still stumped, basically, is what he said. He's not sure what the hell they saw.
Well, then there's, you know, Bigfoot, of course.
Yeah, here we go. Loch Ness Monster in the sky. Bigfoot right in the Loch. You know, I saw Bigfoot on the Loch Ness Monster in the sky.
Right in the Loch Ness Monster.
Put them all together, make it easy. No, there's something there, but I'm not sure what it is yet.
Hey, I gotta run some weird thing past you guys, who Mark and Leonard, and I don't know if Barb's handy, but there's a person on Facebook on one of these groups that keeps posting images of the sky that are not real. But she has her own Facebook page that advertises her photography. And she has a web page. And she calls herself a landscape photographer, never mentions taking artistic license, and never mentions compositing images, which is what she's doing. And she gets hundreds of likes for her pictures, and they're compelling. They're good astrophotography. They're compelling, but they're all composited together, and you can tell, like, the planets, the moon was way too close to them than compared to where it was. And all I did was I called out. Someone mentioned that that didn't look right. And I just chimed in on that, under that comment, and said, that's because it's a composite. And she got all angry with me.
Wow.
And we had a back and forth on the messenger on Facebook. And I just said, you aren't being honest with your photography. All you need to do is say you're compositing things. She says, I give all my settings. Well, that's not Photoshop. You're talking about what your camera's doing. And I don't know if any of you guys know Keith Gleason from the Summers Bosch, who's retired now.
Yeah.
Yeah, he's on that group too. And I messaged him and he said, yeah, I was tempted to say nice exposures. Well, okay, I'm not the only one. So we went back and forth a little bit and she's stonewalling me. And I said, okay, let me throw a thought experiment at you. Twice a year at Monument Valley, the shadow of the West Mitten sets on the East Mitten when the sun is shining. What if, and oh, this is such a big deal for photographers that all the rooms are booked up on those weekends. What happens if once every 10 years the moon is rising and let's say the clouds get in the way? What do you do? Do you paste the moon in there and feel guilty about it or not? Or do you let someone else do it and then do you get pissed at them? And of course she said, good day. Well, that's not the end of the story. Today, her fiance, who's also a photographer, said, there's been someone that's been disparaging my and my fiance's work. I never said anything about him. In fact, in the messaging back and forth, she said, you always give him likes on his photography. And I'm thinking, well, that's because he isn't compositing things. Anyway, it's released a whole shitstorm on Facebook about this. And I'm not exactly sure how to deal with it at this point.
Yeah, I know what. Just tune out.
Yeah. Yeah. Well, if on the UFO, UAPs, whatever they are, there's so much hucksterism going on.
Yeah.
People just want to get on there. And I mean, now we have experts that are UFO fakers. They're taking everything those people put out.
Like MUFON.
And drones are everywhere, and people are making UFO drone pictures and shit. So it's going to get really confused. And
You
frankly,
can put LEDs. You can put LEDs on drones, for instance.
I know. I've seen all this stuff. It's just, and it feeds a whole cottage industry of fanatical, believers that want to show something that, see, I told you so. And that's what's the problem. Some of this is going to be, if the UFOs ever come here, we're going to be all confused because we'll make it up.
Everybody will think it's from Disney.
Yeah, it's a Disney product.
Well, I guess
but it's always been there. I grew up in San Diego. The thing that I anchor my interest in this, George Adamski was one of the early UFO pioneers. I mean, he was in Mount Palomar, up there in Mount Palomar coming down. He just got back from Venus. He had pictures of him in a UFO craft. And I mean, I bought his books. I read all those books. And there's a lot of, I still have them, Inside Outer Space. And, the guy,
well,
that's my website.
We can invoke Carlos Castaneda too.
Yeah. Well, I tell you the one that really nags at me. What do you think about this? Velikovsky, as far as his early thoughts about planetary collisions and reformation of the solar systems, and Sagan took him on and thought he was a huckster. And you look at today with some of the theories about planetary formation, and was he off? Was this guy totally crazy, or he was a Soviet theoretician, if I remember right?
Well, I think he was ahead of his time in a certain way, even though he might have been off to a large degree too. But in the last 10, 15 years, all the computer modeling shows all kinds of weird stuff about the formation of the solar system. Yeah. Like, once Neptune was closer than Uranus and they traded places. I mean,
Yeah.
how wacky is all that?
I don't know. I don't know. You know, this guy was, you know, probably deserves. I got one of his books, I think, or a book in my library somewhere. But he was on to something. He may have been off on, but on the big scale of things, I think he was trying to say just what you did. There was a lot of chaos going on here that we didn't appreciate other than 10 or 15 years ago. And maybe that's what he was getting to. He just thought the, you know, but yeah, anyway.
If Bob Grimm was on, he knows all about it because Southwest is doing all that planetary modeling.
Oh, you know, Canup and Robin, and all those people are got some great.
Oh yeah, Robin Knipe or whatever her name is. Knipe?
Yeah.
Yeah.
Who's the guy we're trying to get to come on the? No, not Robin, but the other guy. There's another guy that's really good too at the Southwest. I mean, he's always coming up with new formation theories. Anyway.
Well, a couple of things. I don't know how long we were going to have to still do Zoom meetings, but I know the guy who's project manager of the Giant Magellan Telescope, and he gives talks now and then. He might be able to give a Zoom talk.
That would be kind of interesting. Well, the new Magellan telescope coming out.
Oh, the Magellan.
Yeah. And then there's that woman who's a Facebook friend of yours, Rhonda Stevenson, who's in the Tau, what is it? Tau Ceti or something institute that they're always trying to talk about space travel or interstellar travel.
Yeah.
She
is she the one that was gave the talk at the museum?
I have no idea because I wasn't there.
Oh, yeah, okay. Sorry. I'm blanking out on her name.
Amanda Hendricks?
Yeah, right. Yeah.
No, this one lives near me, and she's younger and she has kids or younger kids, 10-year-olds or something, but she's always putting content on Facebook about interstellar travel, and she forwards or shares, Leonard, your posts a lot.
What?
Your posts.
Your posts to Facebook. She forwards them or shares them. But I actually messaged her. She said, yeah, she'd do something like that. So I don't
I got one guy that I can probably get on here at some point that's pretty level-headed, you know, whatever that means. Les Johnson works at NASA Marshall. I've known him for a long time. Les is really running some interstellar propulsion studies. It's pretty compelling. Nice. You know, things are happening there. You know, you got to keep an eye on that. But there are some things, you know, and particularly if this Proxima Centauri thing turns out to be something meaningful. You said it. I think we're right there, and that's close.
It's so close. We could get life signatures like methane, water vapor, oxygen, ozone. I don't know about ozone because it's a red dwarf, but you know.
Yeah, well, that's the thing. How do you know, what are that's the key. You know, are we going to agree on what the biosignatures are for techno life elsewhere, and do we all agree that you know, once we see those, is that something we're all going to raise our hand and say, yeah? There will be somebody that will say, well, it's caused by, you know, neutron stars or something. I don't know. There'll be some fucking thing. But yeah, we got to get some kind of you know, a judge here that says, you know, that well now that's a 99.9.
I think if we get a laser signature, that would
Yeah.
kind of clinch it.
Okay, well, like I said, I think some people will have lasers, others won't. They'll have other, you know, for all I know, they're sitting there, you know, telepathy, you know, on
Yeah.
other planets. We're picking up it now. We discount it as a bad dream.
Right. No, that's true.
Well, we're dealing with what we know in the electromagnetic spectrum. So
Yes.
Yeah,
kinda,
which
we're
is
kind of
bogus.
limited to that.
Yeah. What do you think? Is that spectrum really worth its gold?
Well, that's all we got.
Are we all living in the Matrix?
Yeah.
Well, I know when you
Well,
look
I
at
don't know.
some of this spooky theory at a distance or quantum stuff at a action at a distance, it makes you really scratch your head.
Multiverse. We want the multiverse. I still want somebody to come out and explain that goddamn thing. I can't figure it out. Or we're part of a game. You know, Elon Musk thinks we're part of a game.
Yeah. Or else we're all part of a sim that's created by someone in the future that is recreating the past just to see if they can figure out what they did wrong or something.
All right, let's go there. We can seal that deal.
Right.
This would be a good talk at the Wonder View with a couple of beers.
Yeah, a couple of beers.
I'm
Probably
looking forward to
two.
that. Better start early.
Okay, I gotta go now.
I gotta go too.
All right.
See you guys.
Barb, are you ready to go? I gotta go. Barb's gonna
Okay,
sign
tell
off
Barb I
officially.
said hi or bye.
Okay.
Happy holidays.
Yeah,
Yeah,
happy
you too.
holidays.
Yes.
We made the mistake of getting this food delivery today, so I'm still trying to wash things down.
Yeah, we're doing good.
Okay.
I let them sit for 3 days and then just say, forget it. It's
Well,
good.
you can't do that with the ice cream.
No, I know. That's a problem.
No, we let some of it sit. So can you see our big telescope back
Yeah,
there?
I can,
I figured
yes.
it out now.
Yes.
Yeah, it's let's see, that's 11-inch Orion. It's on
looks
the
like a mead.
No, it's an
mead.
Orion. It's Orion.
No lion?
See, this is a mead over here. That one. No, this is an Orion. Wait a second. Let me get in a second. 11-inch Cassegrain Orion.
Okay. Wow. Nice.
It's got this wonderful little ramp to take it out to our deck, 4 inch, take it down 4 inch. It's got a $250 scope buggy.
Wow.
And hasn't been out for about 10 years.
Oh, that's when you've, okay, cool.
That's the one we need help with.
Yeah, well, tomorrow
Come on up.
for the conjunction.
Oh, wouldn't that be nice?
Yeah.
I don't think
Oh,
it's so
yeah.
cold.
Oh, yeah.
Oh, I
Fortunately,
know.
that wind went away.
I'm
Yeah.
hoping tomorrow the weather will be a little better. The scene now. Did you ever look at the clear sky chart?
Yeah,
Some
yeah.
links. Yeah, you
The-
sent me some links, didn't you?
Yeah,
Yeah.
the scene today was supposed to be gray. In other words, poor. It wasn't even rateable. It was so bad. Like that's when you can see the moon shimmering with the naked eye, you know? So tomorrow's supposed to be better, and with any luck, we'll get something. But I'll be ready for it, I think.
Yeah.
That's great. And Mark, did you say you're going to try to take some pictures of it too?
Well, I don't know if it's clear enough. I'm not going to spend a lot of time trying.
Mark, you ought to get that P900 out.
I know. Well, that's what I'm going to use. That's what I used to get the sunspot 2 weeks ago.
Oh, cool.
Yeah. So I'll load that up next meeting.
Well, yeah,
'cause I
definitely.
think you could do pretty good with that.
Yeah. Yeah.
I mean, I'm gonna use a crop sensor at 1280 millimeter focal length, so that'll be like close to 2000 equivalent. But we'll see how I do.
Yeah. Right. But yeah, I'm not gonna, I'll give it a shot. We'll see. So I'm gonna head out, but
All
good
right.
talk.
Yeah,
Thanks
just
for,
wanted you to know that these are actually stars that we
Oh,
got.
wow.
Aren't those cool? $16, 45 feet long.
Wow.
And we had them outside. They're colors. You can't really see that.
Yeah, I
so
can
well.
see some of it.
Yeah.
Very cool.
Yeah, it's kind of, yeah.
All right.
Yeah, bright colors. And we had them outside in the 45 mile an hour wind, but with this predicted to be 75 today, I brought them in. Anyway, well, happy holidays, you
Hey,
guys.
Barbara, can you hear me?
Yeah, George. Yeah.
You know, because these discussions are so much fun, on the off weeks, 2 weeks between the meetings, we should just, hey, this is going to be a Zoom discussion and complaint section where we're all going to talk about things of interest.
Yeah,
that can be more fun than a presentation, right?
Sure. Yeah. And we could talk about anything.
Yeah, and if you come, you come. If you don't, you don't. People don't have to show up.
What do you think? Just send it out to like we had 28 people tonight. Yeah, if it was just a discussion, especially as we got the holidays and everything. So
yeah, hey, we're gonna talk
what's
about
2 weeks? What's 2 weeks from tonight? What's that date?
The first will be on the Thursday, Friday. So it'll be a week after that. It'll be about Saturday would be the 9th, Saturday would be the 9th and Sunday would be the 10th.
We could do that,
Yeah, Sunday nights seem to work well with people.
And
Okay, I'm gonna go. Bye.
Yeah. Anyway, think about sending that out, Barb. Think about sending that out, Barb.
All right. Happy holidays. I'm getting off too.
Bye, John.
Hey, love you guys. Mwah. Thanks for being here. Bye-bye. Let's see. I guess I can end it. Yeah. Okay. And meeting for